So welcome to the video lecture series on principles of compiler design. This is Dr. K. Sivabalan, and we will be discussing about today the concept of optimization of basic blocks. So basic blocks is an essential component in code optimization. Basic block is actually used to eliminate a common sub-expression. So it will actually eradicate the unwanted computations which is taking place while improving the efficiency of the code. So we'll be learning about the various techniques which is connected with the optimization of basic blocks. So in general, there are two types of transformation as far as optimization of basic blocks is concerned. The first one is called as structure preserving transformation, and the next one is called as algebraic transformation. So we'll go and discuss what this exactly means. So structure preserving transformation is actually bifurcated in four segments. The first one is called as common sub-expression elimination, which we have already discussed in the various optimization techniques. And the second one is called as dead code elimination. This is also a familiar topic. And the third one is renaming the temporary variables. And the last one connected with this is called as interchange of independent and adjacent statements. So we will learn with examples about each and every topic which is actually having nexus with structure preserving transformation. So what is meant by common sub-expression elimination? So if you have an expression inside a basic block and such basic block actually generates the same value, then such kind of expression should be removed. So it is actually a redundant task. Okay, replicated task is again and again done. So it actually makes a burden in the computation. So in order to do that, we will take an example. Let us assume that we have a basic block with three statements: x is equal to a plus b, y equal to c minus d, and z equal to a plus b. When you closely observe this, the first statement and the third statement has identical values, because a and b value does not change during the course of this basic block. It always remains the same. So a plus b will always compute the same value. So x and z will have the same value. So unnecessarily computation has been made here by performing an addition of a and b. So to eliminate that, we will compute this value. We will take the value of x and assign it to z. So unnecessary one computation burden will be eliminated. So this is called as common sub-expression elimination. If value does not change when you actually apply an expression, then such kind of expressions, if it is replicated more than one time, then you can just replace that with the respective variables. Now the next one is called as dead code elimination. For instance, if you have a live variable and the subsequent expressions or statements does not use that live variable, then that is considered to be a dead code, and having such kind of memory is actually a waste of storage here. So such kind of code has to get eliminated. So we will take an example. In this case, we have two basic blocks here: c equal to a plus b and d equal to x minus y on the first basic block, and e equal to d star 10 and e equal to e plus 1 is on the second basic block. Now, when you actually have a deep analysis of these two basic blocks, you can see that the statement c equal to a plus b, that means the variable c is not applied anywhere after that. Either it is not applied in basic block 1 or basic block 2. C value is not at all used. So such kind of code is called as a dead code. So we have to eliminate such codes here. So we can just eliminate that code and then keep all the remaining code as it is. So this is called as dead code elimination. You can see here the basic blocks being transformed, where c is equal to a plus b got eliminated, and the rest of the codes is actually remaining on the same point. Now we will go for the third one called as renaming temporary variables. So why we have to rename the temporary variables? Say for example, in such certain cases we have to preserve the value of it. When temporary variables keep on changing, then the previous value we cannot restore it back. So in that case, if we want to preserve it, then we have to rename it. So in this case, we have taken a basic block T1 equal to A plus B, C equal to X minus Y, and T1 is again used here by multiplying 10. Now T1 value is getting updated in the third statement. And the fourth statement, we are again using the same T1, updated value of T1, and we are adding C to store the value in D here. So this is the basic block. Now when you closely observe it, in the first statement T1 will have a value, and in the third statement T1 value is getting updated. So if I want to take the previous value of T1, then that value will be missing, isn't it? So how to preserve that? So what I have to do here is, now what I can do is, instead of T1 in the third statement, I replace the T1 by T2. So T1 value will not get updated here, so T2 value will be there. Okay. Now when you come to the fourth statement, we are actually applying the value of updated value of T1. Similarly, in this case, since T1 is actually replaced by T2, we actually apply the value of T2 in the fourth statement. So this is called as renaming the temporary variables. And the last one is called as, the fourth one is called as interchange of independent statements. So when you can interchange it, so when two statements are interdependent, if two statements are not interdependent, then such statements can be interchanged here. Okay, so now A equal to A plus 1, we take a basic block, B equal to B plus 2, and C equal to A plus 3. Now when you analyze this, the first statement and the third statement are interdependent. I mean, first A is actually added with 1, and then the updated value of A is actually applied on statement number 3. So if you try to change these two values, what will happen? C will get a wrong value. If you just interchange the first statement and the third statement, C will have a wrong value. So what we have to do here is observe the first statement and the second statement. And you can see that A and B are not interdependent on each other. So in this case, we can change these two statements. So we can transform this two statement by changing it. So I'm just swapping these two statements order. First statement I put B equal to B plus 2, and then second statement is A equal to A plus 1. So no way it actually affects the computation or computational values of the entire basic block. This kind of statements is called as interchange of independent statements. Now, the last one is called as algebraic transformation. So what is algebraic transformation? So when you have an expression and it produces the same value, then such kind of transformation, such kind of statements is called as algebraic expressions. In this case, we have a basic block x equal to x star 0. When anything is multiplied by 0, you will get the same value as 0 here, isn't it? So there is no meaning in this expression. And the second statement t equal to y minus 0. So when you subtract 0 from any value, you will get the same value as it is. 0 does not make any sense here. So this expression does not make any sense. Now when you come to the third statement, z equal to s star 1, obviously we will get the same value of s here. Okay, so no meaning in multiplying with 1. So this is called as the waste of expressions, which actually take a computational value here. It will take a computational burden, but no impact in the change in the value. Okay, there will not be any change in the value, so you will get the same value. So this kind of unnecessary expressions has to get eliminated. So how to transform that? It's called as algebraic transformations. Now this can be transformed as, instead of x is equal to x star 0, directly assign 0 to that. So because anyhow you are going to get 0 as a value. Now t equal to y minus 0, we can directly represent it as y here, because always you will get the y value and you subtract 0 from it. And then z will be having the value of s here. So since you are multiplying with that, so unnecessary expressions can get eliminated. So this is called as algebraic transformations. So that's about optimization of basic blocks. Thanks for watching the video. Have a good day.